Welcome back, everyone. Last time we talked about the law of cosines to solve a triangle. Today we're going to talk about the law of sines as a way to solve a triangle. The law of sines is a lot easier of a formula than law of cosines, but there's a weird situation that comes up. So there are three scenarios when you would use law of sines. You would use law of sines if it's a side between two angles, so we call that angle side angle. If it's two angles and a side, angle, angle, side, or if you have two sides and the angle not between them. This is the one that we're going to have to pay attention to that we're not going to talk about today. In general, I don't memorize these, you need to, but I always forget these. Here's what I remember. I want an angle and the corresponding side. So if you have side A and angle A, then this is what you're going to use. So the ambiguous case is side, side, angle. We're not going to do any of these today. Check out the next video for the ambiguous case. Here's the formula. The sine of the angle over the side across from it equals the sine of a different angle over the side across from it. And it's the same for the third angle. Find an angle and the side across from it. Also, you could flip these if you wanted to. It doesn't change the problem. So let's take a look at an example problem. These are pretty easy. Let's solve using the law of sines. So I have two angles and a side not in between them. So I have angle, angle, side. The key thing that I see is that I have a side and an angle that match up. So the law of sines is what I'm going to use here. So the first thing I'm going to do is find the third angle because you need to find all three sides, all three angles. So I know that I have 105 plus 35 plus whatever angle A is has to be 180. So A in this case is going to equal 180. Okay, let's move this over. 180 minus 105 minus 35. So angle A in this case is going to be 40. So now I need to figure out the other two sides. Okay? I know that sine of 35 corresponds to 7. Once I have that ratio set up, I can use this to find the other sides. So let's find side A. That is the sine of 40, because I know that angle is 40, over A. Because I know both angles and one of the sides, I can cross multiply and figure out what A is. So here I get A sine 35 equals 7 sine 40. So I get side A equals 7 sine 40 over sine 35. Grab your calculator. Let's do that. Let's put a fraction in here. 7 sine 40 over sine 35 equals 7.845. So side A equals 7.845. And that makes sense because this 35 degrees across from a 7, this 40 has to be more than that 7. Now, let's use the same ratio. Sine 35 over 7. I could use the ratio I just found, but I'm going to stick to the one I have, to find side C. So sine of 105 over C. Same as before, I'm just going to cross multiply. C sine 35 equals 7 sine 105. I'm solving for C, so I'll divide it over. I'm sorry, wrote that wrong. 7 sine 105 over sine 35. I'll do that in the calculator. Seven sine 105 over sine 35, and it gives me 11.788, which is good. I wanted this side to be the biggest. What was it? 788, 788. So, as you can see, law of sines goes a lot faster than law of cosines. Just find an angle and a side across from it, set up a proportion with something that you don't know. Next time we'll talk about the ambiguous case, the side-side angle case. There you have to have two triangles.